This video is for writing quadratic functions. So the first thing we're going to do, we're going to write quadratic functions from a graph, from a solution, and from its roots. So from a graph, it says write a function for the graph as shown to the left. Identify the vertex of the graph. So that's our first step, is identify the vertex. So our vertex is down here, it's a minimum, and it's at 3, -4. And then we need to identify a given point from the graph. And you can use any point. Always try to use one that they've kind of marked. So we're going to use this one here at 5, 0. And then we're going to fill in the vertex form with the values that we found. So our first one is f of x, and that is our y value from the point that we picked. So that's a 0. Then we've got x, so the x value is again from that point that we picked. H is the x value of the vertex, so that's a 3. And then k is the y value, and so here that's a -4. So now we're going to solve for the a value, and I'm going to do this on a different sheet of paper, so I've got room to work. So I've got 0 equals a, and so 5 minus 3 is 2, and we're going to square that, and then I'm just going to do minus 4 at the end because it's better than plus a negative. So 2 squared is 4, so I'm going to make this a 4a minus 4. Then I'm going to add 4 to both sides. So now I've got 4 equals 4a. This cancels, and then I can divide both sides by 4. So 4 divided by 4 is a 1. 4 over 4 cancels, equals an a. So again, when I'm canceling this out, it's really turning it into a 1. So my a value equals 1. So my equation is going to be f of x equals, so the a value goes first. So since it's a 1, I don't have to write anything. We use the invisible math. And then we've got x minus 3 squared, and then minus 4. So the only two numbers that you plug in here are your h and k of your vertex. So now it says convert the vertex form of the quadratic function to standard form. So remember when we do this, so we've got x minus 3 squared minus 4. The first thing we do is we square that x minus 3. So x times x is x squared. Outside, x times -3 is -3x. Inside, -3 times x is -3x. -3 times 3 is a +9. And then we've got a -4. So we can combine like terms here. So I would have f of x equals x squared. -3x minus 3x is a -6x. And then 9 minus 4 is a +5. Remember, you can always graph the two forms, check the tables, check the graphs, and make sure they line up. All right, so from solutions, the solutions to a quadratic equation are 2 and 6. What quadratic function could be used to represent this problem? Well, if we know these are our solutions, then we know that the factors of the quadratic function are x minus 2, remember you kind of flip it, and then if it's a +6, x minus 6. So now we can convert this to standard form by simplifying that equation out. So x minus 2, x minus 6, alright, x times x is x squared, x times -6 is -6x, -2 times x is -2x, -2 times a -6 is a +12. So if I combine like terms here, I'm going to have a -8x. So the quadratic equation would be f of x equals x squared minus 8x plus 12. All right, it says write 3 other representative functions that would also have the same solutions as listed in the problem. Graph the functions on the coordinate plane to prove that the solutions are the same. So, I'm trying to remember what I did. So one thing that we can do, we can multiply this entire quadratic function by a -1, and it would still have these two solutions. So if I did f of x, and I just change all the signs, -x squared plus 8x, and then minus 12. Okay, so again, when you're graphing these, you can always go to your y equals here, -x squared plus 8x minus 12. So we can graph it. It's easier though if you look at the table. So I can see where my vertex is, because on either side of that number, the y values start to decrease. So I know 4, 4 is the vertex, and then I've got 3, 3, 5, 3, and then 6, 0, which is one of my solutions. And then I've got 2, 0, which is my other solution. So where I'm seeing that at is here. 2 and 6 are my solutions. That means this quadratic needs to cross at 2 and 6. And then I'm just going to do one more so that these notes aren't really long. All right, so the other thing we can do, we could multiply this entire thing by 2. F of x equals, all right, 2x squared. 2 times a -8x is -16x. And 2 times 24 is a positive 24. The other option that I could do, I could cut everything in half as well. But we're just going to do this one so I can keep these notes moving for you guys. So 2x squared minus 16x plus 24. All right, so we can kind of see what this one looks like. Second table, we're going to find the vertex. The vertex should be, let's see, right here at 4, -8. So again, this time all the y values are getting bigger. So 4, -8, and then I've got 3, -6, 3, -6, and 5, -6. And then I've got the same points here, 6, 0, and 2, 0. And so again, those are the solutions that I'm looking for. And so this quadratic would have the same solution. So solutions don't represent just one specific quadratic function. So sorry, my parabola's a little wonky there. All three of these have the exact same solutions. They're all going to cross the x-axis at 2 and 6. All right, and finally from roots. Roots are the same thing as solutions. So a quadratic equation has a double root of 7. What quadratic function could be used to represent this problem? So first thing we're going to do is we're going to write the factors. If the root is 7, that means the solution is 7. So my factors would be x minus 7 and x minus 7. So f of x equals x times x is x squared. So, I shouldn't have done that. Should do it here. All right, x minus 7, x minus 7. So I got x squared. X times a -7 is a -7x. -7 times an x is a -7x. -7 times -7 is a positive 49. If I combine like terms, I get a -14x. So minus 14x plus 49. Now, same thing with solutions. There are multiple quadratic equations. So I'm going to write 3 other representative functions that would also have the same solutions. So first thing I'm going to do is I'm going to multiply all this by -1. And what that does is it just changes the sign. So x squared becomes -x squared, -14x becomes positive 14x, positive 49 becomes -49. Okay, I can multiply the whole thing by 2. So 2 times x squared is 2x squared. 2 times a -14x is a -28x. 2 times 49 is a positive 98. And so what this thing, when it has a double root of 7, let me show you what it looks like in the calculator so you have an idea of what visually it would look like. So x squared minus 14x plus 49. So if I graph this, a double root means that it just comes down and it barely grazes the x-axis right there at 7, 0. And so the rest of these would do the same thing. So if I graph the next one, go down a line here, negative x squared plus 14x minus 49. If I graph that one, you can see that it just flipped it, it reflected it, but it's still the same solution, the same roots. 2x squared minus 28x plus 98. So now you can see that it's skinnier. And so what this is doing, these are called transformations, and we will get into that at the end of this unit. But again, they're all sharing that same double root of positive 7. So the last thing I'm going to do, I'm going to divide this whole thing by 7, because 14 is a factor, or a multiple of 7, 49 is a multiple of 7. So if I divide x squared by 7, that would be 1/7 x squared. Or you could put the x on top here, x over 7 squared, same thing. All right, negative 14x divided by 7 is negative 2x, and then 49 divided by 7 would be a positive 7. So again, to show you that this as well will graph with the same root, x squared minus 2x plus 7. If we graph it, you can see that big pink parabola come in. So you can see that multiplying the entire quadratic by a number greater than 1 makes the parabola skinnier. If we divide the entire thing or we multiply the entire thing by a number less than 1, it makes it big and fat. It stretches it out.